Hi guys, today we're going to be taking notes on page 22 and 23 in our ISN. I hope you watched the video on how to glue it in, which is the video is attached to this assignment. So please do that first and then we will take some notes now on page 22. The notes are actually going to be just examples for you to follow, and then you guys can do the work on page 22 on your own. So rational numbers. What is a rational number? A rational number is a number that can be written as a over b, or as a fraction a over b, where a and b are integers and b cannot equal 0. Remember, b cannot equal 0 because we can't have a 0 in our denominator. To add rational numbers like negative and positive fractions and decimals, follow the same rules as adding integers. Remember, when we're adding integers, we follow that song. Same signs add and keep, different signs subtract, keep the sign of the bigger number, and you'll be exact. So right over here, we have a negative 8.9 plus negative 0.03, two rational numbers that are being added with the same sign. So we're going to add and keep the sign. But before we do that, because they're decimals, we want to set them up vertically and match our decimal places. That way, we can make sure we're adding the correct number together, correct numbers together. I'm going to add that 0 there because it doesn't change the actual number, but it will help me add 0 plus 3 is going to give me 3, and 9 plus 0 is going to give me a 9. I'm going to transfer my decimal place down. 8 plus 0 gives me another 8. Again, remember, same signs, add and keep, so we're going to keep that negative sign. So our answer for this problem is negative 8.93. Again, these examples are not on page 22. These are just examples that I'm doing, but I would like you to work on page 22 after you watch this video. Okay, next example, negative 1/5 plus 3/5. So we have common denominators for both of these fractions. If you remember, when we have common denominators, we don't have to worry about changing the denominators because they're the same already. All we have to do is take our numerators and add. Well, we're adding negative and a positive, so again the song goes back to same signs add and keep, different signs subtract and keep the sign of the bigger number, then you'll be exact. I'm going to rewrite this, negative 1/5 plus 3/5. Subtract 3 minus 1 gets you 2 over 5. Keep the sign of the bigger number. Well, 3/5 is my bigger number, and that's a positive, so my answer is going to be positive. So answer for this problem is 2/5 positive. Okay, now we're on to uncommon denominators. We have negative 3/4 plus 2/5. When we have uncommon denominator, whenever we're adding or subtracting, we must first find a common denominator. Well, what's a common denominator for 4 and 5? It's going to be 20. So I'm going to multiply this denominator by 5 and this one by 4. And whatever I do to the bottom, I must do to the top. So I'm going to multiply my numerator by 5, and I'm going to multiply this numerator by 4. So 5 times 3 is 15. Over 5 times 4 is 20, and I'm going to transfer that negative sign. Please don't forget those because they will give you a wrong answer if you drop those. So 4 times 2 is 8, 4 times 5 is 20. Same signs add and keep, different signs subtract. Our 15 over 20 is negative, 8 over 20 is positive. So I'm going to subtract 15 minus 8 gives me 7 over 20. Keep the sign of the bigger number, then you'll be exact. So we have a negative 7 over 20. So my answer for this problem is negative 7 over 20. Okay, now we have negative 3 and 3/10 plus 4 and 1/3. These are mixed numbers. So before we find a common denominator, we have to convert these into improper fractions. And how you do that is by multiplying the denominator by the whole number, then adding your numerator to it. This should all be reviewed, so I'm going kind of quick. Again, multiply your denominator by the whole number, then add your numerator. So 10 times 3 is 30, plus 3 is 33. Over 10, you keep the same denominator and transfer that negative sign. Add that to 4 times 3 is 12, plus 1 is 13, over 3. Now, we have them in improper fraction, but we have to get our denominators. Well, what's a common denominator between 10 and 3? It's going to be 30. So we're going to say multiply this side by 10 and multiply this side by 3. Again, whatever you do to the bottom, you must do to the top. 3 times 33 is 99. 3 times 10 is 30. Transfer that negative sign. Move that add or addition sign. 10 times 13 is 130. Over 3 times 10 is 30. Now that we have common denominators, we can go ahead and use our integer rules to add our numerator. So different signs, we're going to subtract 130 minus 99 will get us 31 over 30. Keep the sign of the bigger number. Well, 130 over 30 is my bigger number, so it's a positive, so my answer is going to be positive. But if you look at this, we're not done yet because we have an improper fraction. Whenever we see an improper fraction, we must convert it into a mixed number. So how many times does 30 go into 31, or how many times does your denominator go into your numerator? It goes into it one time with a remainder of 1, and keep your denominator the same. So our answer for this problem is going to be 1 and 1/30. Okay? Go ahead and do the practice problems on page 22. Label it adding rational numbers. Okay. And I did an example of all 4 of these. So go ahead and go back and look at the examples if you need extra help. Okay, page 23, subtracting rational numbers. Well, it's the same thing. Again, rational numbers are any numbers that can be written as a over b, where b is not equal to 0. And to subtract rational numbers, just like negative and positive fractions and decimals, follow the same rules as adding integers. So now, when we're subtracting integers, the first thing we have to do is keep, change, change. So you're going to keep your first number the same, negative 12.41. Change that subtraction sign to an addition sign and change the sign on that second integer to the opposite. So it's a negative 9.95, so it's going to be a positive 9.95. So now we're adding different sign numbers, so we're actually going to subtract and keep the sign of the bigger number. But before we start subtracting decimals, we have to line them up. Make sure those decimal places line up. And I like to leave a little space so it's easier to line up your numbers. 9.95. And we're subtracting this. 1 minus 5, can't do that, so we're going to have to borrow from that 4. That turns into a 3. 11 minus 5 gives us a 6. 3 minus 9, can't do that, must borrow. 13 minus 9 is actually 4. Bring down that decimal. 1 minus 9, can't do that. Let's borrow again. 11 minus 9 gets us a 2. So we're left with 2.46. However, we have to go back to that adding integer rule. Different signs, keep the sign of the bigger number, then you'll be exact. 12.41 is bigger than 9.95, the absolute value of these numbers, right? So we're going to keep that negative and put it in front of our answer. So the answer for this question is negative 2.46. Okay, subtracting fractions with common denominators. First thing, change, keep 7/12 the same, change that subtraction to an addition, change that sign on the second fraction to the opposite, so that's going to be 13/12. I don't need the parentheses, but it's there, so we'll work with it. So now we have common denominators, so we just have to add the numerator. 7 plus 13 is going to get us 20. And those were same sign, so we just add and keep the sign. Both signs were positive, so our answer is a positive 20/12. Ooh, I forgot a step though. We can reduce this. Divide by 4, yep, 5/3, wow. And how many times does 3 go into 5? Once, with a remainder of 2/3. Okay, so I'm going to erase my answer because my final answer is not 20/12. My final answer is 1 2/3. Okay, on to subtracting fractions with uncommon denominators. Again, first thing we're going to do is keep, change. So keep that negative 1/3, change that subtraction to an addition, change the sign of that second fraction to a positive, 9/4. It just so happens that all three of our fractions have been negative, but if it was positive, we'll see that over here. So I was going to go back and show you, but we'll look at that example, next example. Okay, so now we have keep, change, uncommon denominators, so we're going to make sure that we have common denominators first. The least common denominator is 12, so we're going to have to multiply this by 4. Whatever we do to the bottom, we must do to the top. Multiply that by 3. That gives us 4 times 1 is 4. 4 times 3 is 12. And don't forget that negative sign. Plus 9 times 3 is 27, and 4 times 3 is 12. Now we have a negative fraction and a positive fraction, so we're going to subtract and keep the sign of the bigger number. So 27 minus 4 is actually going to be 23/12, and 12. My bigger number is 27/12, which is positive, so my answer is going to be a positive number. Again, we have an improper fraction, so we're going to convert it into a mixed number. 12 goes into 23 one times with 11 remaining. So my final answer is 1 11/12. Okay. Uh-oh, did I do something incorrectly? Nope, that's right. Okay, good. When I did the problem earlier, I got a negative number, so just had to double check. Okay, so now, again, we're on to mixed numbers with uncommon denominators. Before we do anything, because we're subtracting, we're going to keep, change first. Keep the first fraction the same, -3 1/2. Change that subtraction sign to an addition sign, and change the sign on the last fraction to a negative. Okay, so now